Hello woodworking and hello math. I came across a situation here that needed a little bit of math, and I'm going to share this math with you here. In woodworking, there are routers. That's not the internet, that's a different machine, okay? So routers take router bits. Here is one of them. This happens to be a chamfer bit that cuts on a 45-degree angle. A nice 45-degree bevel angle into the edge of wood. It can be a straight cut or it can be into a round piece of wood as well. It could be plastic, whatever. So these router bits here are, they have different diameters, small, bigger, even bigger, but there are some dimensions given for them. That's useful, but none of them is what I want. What I want is the depth of cut here. What is the thickest piece of wood that this 45-degree chamfer bit is gonna cut through? That's what I wanted to know, the depth of cut. Now these dimensions here are nice, but none of them are the depth of cut, because the depth of cut is running not along the cutting edge, but from here to here. And that's not listed, and that needs a little bit of a math. So let's take a look at the math here. This is the same image, the depth of cut calculation. And I grabbed one of these, the 1.5" diameter chamfer bit, and I just copied the numbers. Why this is not A, B, and C? Because A is the large diameter on the bottom, B is just visually the length of the cutting edges, just listed here, and C, 1/2 inch, that's up top here. I want to go back to this page here. The specifications here says 1/2 inch or 8 millimeters. 1/2 inch does not equal 8 millimeters. 1/2 inch is there, 12.7 millimeters. So these are not equivalencies, these are just, can be, the router bit can be specified with either one of the shank diameters. Just a side note. So let's do the math here. How do we do depth of cut out of this one? Well, I replaced the green router bit here with a blue trapezoid because one just fits. The trapezoid is a useful math shape because it can be calculated with trigonometric ratios. I'll show you shortly. So the blue trapezoid is, yes, it's upside down. Usually the long side of it is on the bottom of the page and the shorter side of it is usually on the top of the page, but this is how the router bit is on the manufacturer's page here. So that's, I'm just cutting it out and pasting it in. So out of this trapezoid I can make two right angle triangles. I'm showing one of them here. Here is the right angle, and because it's a 45-degree chamfer bit, it's gonna get me a triangle with two 45-degree corners. Let's just zoom in to see what's going on here. There. So the depth of cut again is this blue double-headed arrow, and depending on which 45-degree corner you pick as your reference, this side can be opposite or this side can be adjacent, or if this is your reference angle, then this is the opposite and that's the adjacent. I hope you're not dyslexic. Either which way, depth of cut is the same blue arrow, because that's how the router bit is oriented in this original picture. So the depth of cut would be again from here to here, or in this picture from this corner here down to about this corner, because this is where the 45, 45, 90-degree triangle is. And then it leaves a little bit of space here because the depth of cut is only this much. So sine equals opposite over hypotenuse, or cosine equals adjacent over hypotenuse. Either which way, the math is gonna work out the same way for the depth of cut. So solving it for the opposite side looks like this. You multiply sine 45 with the hypotenuse, And hypotenuse is a given number. It's right here in this picture. B, the cutting edge, is your hypotenuse. That's what's listed here. Half here, 3/4 there, and 1 3/4 there. So for the hypotenuse number for this particular router bit, I plug in the 3/4 of an inch in decimal form, 0.75. Either which calculation will equal to the same one number, 0.53 inch plus change. Let's just call it half an inch plus a hair, okay, for depth of cut. And of course the calculation can be repeated, so sine 45 times 0.5 or sine 45 by 1.25 here for the other router bit to get their depth of cut. So that's how the math goes. It's fairly straightforward, and I wish they listed it here. I don't know why it's not done, but there you have it.